Good evening, everyone. My name is Lauren Temple, and I'm here today to discuss kinetic and thermodynamic control. Just to give a quick overview, I'm going to go over the sections that I'll be discussing tonight. First part being what is kinetic control, examples of kinetic control, what is thermodynamic control, examples of thermodynamic control, a comparison and contrast, and a conclusion. So the first part is, what is kinetic control? And kinetic control is a reaction in which the product ratio is determined by the rate at which the products are formed. So kinetic control has a lower activation energy, and it also has less energetically favorable products, meaning that it does not require a lot of energy to create said product. This also means that kinetic control usually occurs at lower temperatures. So lower temperatures are able to form kinetically controlled products. And that also means that the products can form very easily. It doesn't take a lot of energy or activation to get the reaction started, and a kinetic product will come from a kinetic control reaction. So an example, as you can see here for kinetic control, is in the bottom corner, you see a diene with a hydrobromide. And as you can see, the top two products are formed from kinetic control. So a transition state for the 1,2 addition has a lower activation rate because it is more stable secondary carbocation. The 1,2 addition will be faster addition than at any temperature. The nucleophilic attack of the bromide on the C2 acylic carbocation is irreversible at this low temperature. The product that forms faster predominates, which shows the kinetic product. Because the kinetics of the reaction determines the product, the reaction is said to be under kinetic control. This basically means that the 80% 1,2 product we see was formed at a low temperature. It was formed faster, which shows a kinetic product and a kinetic control. Moving on, what is thermodynamic control? So thermodynamic control is a reaction in which the product ratio is determined by the relative stability of the products. Thermodynamic control has a higher activation energy. It is also more energetically favorable. That means that more energy required will be more favorable. It also means that it takes more time and dedication and heat to form the product with thermodynamic control. We also know, as stated before, a thermodynamic product will come from a thermodynamic controlled reaction, meaning that more energy that's put into the reaction will form a thermodynamic product. So using the same example, when thermodynamic control happens at 40 degrees Celsius, we see that the 1,4 product is actually more favorable because it took more energy and more time, and it probably was produced at a higher temperature. So it says the 1,2 addition is still the faster addition, but at 40 degrees Celsius, the bromide attack is reversible. The 1,2 product ionizes back to the allylic cation, and at 40 degrees Celsius, an equilibrium is established, which favors the most stable product. The 1,4 addition is the most stable product because it has a more substituted double bond, as you can see here in the example. Because the thermodynamics of the reaction determines the product, the reaction is said to be under thermodynamic control. So just to backtrack and kind of go over a comparison and contrast, both kinetic and thermodynamic control have transition states that energy can be transferred to. And both reactions have reactions taking place, meaning that a product will form either way when the reaction occurs, and they're both similar in that sense. However, on the contrast side, kinetic control has reactions that have lower kinetic energy and temperature, while thermodynamic control has reactions that have higher kinetic energy and temperature. But I mean, that makes sense. When there's lower energy, it doesn't take that much of a temperature, a high temperature, for a reaction to form. Whereas if it takes more energy, it'll need heat or some type of catalyst to make the reaction to form. So in conclusion, kinetic and thermodynamic controls are both really important when it comes to chemical reactions. Kinetic control means that there's a lower activation energy, lower temperature for the kinetic control reaction, and a kinetic product is produced. Thermodynamic control means that there is a higher activation energy, higher temperature for the kinetic control reaction, and a thermodynamic product is produced. So that is the end of this presentation, and I hope that everyone watching is able to learn something from this, and I hope you all have a very great night. Again, this is Lauren Temple. Thank you for looking at my presentation of kinetic and thermodynamic control.